Safe and happy learning. This is 50th video being telecast from this channel. I acknowledge your responses. The differences between current and power transformers are favorite questions of many interviewers interviewing the candidates for appointment of electrical engineer. See here a system of current transformer is shown in this figure. This is a current carrying conductor that is treated as primary. And here this is CT and these are CT turns. This is secondary of the CT. This is connected to an ammeter or an energy meter or any other meter. The CTs are categorized as instrument transformers used for the purpose of measurement and protection. It must have very low impedance, that is, for design of CTs, the current densities are selected about 1.5 ampere. Current density 1.5 ampere per millimeter square, and flux density as low as 0.1 Tesla flux density. It is pertinent to note that Bureau of Indian Standard have allowed 1.5 Tesla for power transformer, but for design of cities 0.1 Tesla is selected as flux density. This is because a great level of accuracy is required in cities. This is measuring current. This is protecting the equipment through relays. If there is little accuracy, the system is at the ammeter or energy meters may read erroneous reading, and an erroneous current may pass through relays, resulting in malfunctioning of the relay. So accuracy is prime factor. Here you can see a current IP flows through, the primary flows through this, and this is current IS is the secondary current. Second is the CTs have low error tolerance. Means the error of ratio between primary and secondary should be as low as possible. Also, the phase difference between primary and secondary should be as low as possible. It has very few turns in the primary, maybe 1 or 2 turns. Now coming to the power transformers, this is power transformers supplied by a voltage AC voltage source V1. I1 is the current flowing in the primary, and a flux phi is generated. Suppose when there is no load, a flux phi will be generated in the core of the transformer. When it is loaded, primary has number of turns N1, secondary has number of turns N2. When it is loaded, a current I2 will flow in the secondary, but simultaneously a current will flow to in a direction to counteract this flux. Okay, the Lenge's law, and the direction of current will be such that it counteracts this flux generated by the primary current I1. But what happens then? Immediately a current over and above I1 establishes in the primary, that is I2 dash is equal to N2 by N1 into I2, where I2 is load component current in primary contracting mm of secondary current I2. So far as design of power transformers are concerned, here accuracy is not prime factor. Here efficiency and economy is prime factor. It has large many turns in the primary in contrast to CT where there is only one turn in the primary. The primary of a power transformer may have a large number of turns. As we learned earlier, it has their power transformers emphasizes more on economy and efficiency. Secondly, a power transformer have many turns in primary in contrast to single turn in CTH. Now, also the effect of load on secondary side we observed that effect when secondary is loaded, it affects the primary. This is not the case with the CT. Matter not, you might have seen burden 5 VA. So what is burden? Suppose this is a CT. How many ammeters or energy meters can be connected with it? Normally, energy meters have a burden of 2 VA. Energy meter burden two VA. So at the maximum you can connect, if the burden is 5 VA, you can connect maximum 2 number of energy meters with this CT. Also, accuracy of energy meters are basically accuracy of CTs. Accuracy classes of CTs are class 1, class 0.5, class 2, 0.2 or class 0.1. This class indicates the total error. If it is class 1, the error could be 1%, plus or minus. If it is class 0.5, the error can be 0.5% plus or minus. So why CTs are installed inside the energy meters? Modern smart meters are composed of static element. They carry a very few milliamperes of current, but the current is rated for minimum 5 ampere. Rather, you might have seen the rating of 5 to 20 ampere or 10 to 60 ampere. So this much current cannot flow, 5 ampere or 10 ampere current cannot flow through the static circuit. So in order to reduce the current, CTs are used inside meters. So revising once again, CTs are low impedance, high accuracy, low error, single primary turn transformers. Power transformers are many turns in the primary, little emphasis on accuracy. Ratio errors are also allowed more than 1% for the power transformers as per Bureau of Indian Standard, and load component of secondary affects the primary, which is not the case with CT. That's all in this video. Thank you. Stay safe and happy learning.